Who wouldn't want to save the Earth? Are you against saving the Earth? It gives us a sense of, that our lives are important, right? I think that people have religious beliefs that either the Earth is fragile or it's strong and resilient. I think it's quite resilient, but that's a religious belief. Yet I think a lot of scientists proceed down the path that the Earth is fragile. For instance, the very first research paper that was published showing satellite evidence that clouds cool the climate system. Okay, this was after the Earth Radiation Budget satellite was launched, and they got a bunch of data back. They analyzed the data. They figured out that clouds cool the climate system, but in the abstract of that paper at the very beginning, they said, yeah, clouds on average cool the climate system, but in the tropics, it's a very small difference between clouds cooling and clouds warming, and that was a delicate balance. Now, where did delicate come from? Just because there's a balance in nature does not mean it's delicate. Delicate is not a scientific word in this context. It may be a very robust balance. And besides, nature is always changing its balances anyway. Things in nature change, and anytime there are changes in nature, there are winners and there are losers, and there ends up being some new balance. That's just the way it is. It's not good, it's not bad, it's just the way it is. Those are some of my ideas. Go ahead here.
I think that the changes in solar activity, and when we look at the globe, the oceans, they are the main factors that influence climate. And as you said, the Earth is always changing, and it is a geological fact.
It may be that solar is the main reason for what's happened over the last 2,000 years. I don't know. I just know there aren't enough people working on this kind of work.
You favor the opinion that the cirrus clouds are warming the climate. But there are also opinions that they are cooling the day.
Okay.
Like the Ramanathan.
Yeah.
Feedback.
Ramanathan's hypothesis was naive because he wasn't a meteorologist. But we'll set that aside. The average effect of cirrus clouds is warming. We can measure that from space. Cirrus clouds trap more infrared radiation than they reflect solar radiation. The question is, as the Earth warms, how do cirrus clouds change? And I think that's what you're asking, is as the Earth warms, do cirrus clouds increase or decrease? I don't think we have the answer yet.
Yeah, I have a question about satellites and the accuracy. How well do these satellites measure the water vapor contents in the atmosphere, and also the cloud cover? Because water vapor is also a greenhouse gas.
Right.
Very strong.
Right. Well, there are difficulties in measuring anything from space. Okay? It's really the radiation is ultimately what you want to know about, the reflected sunlight and the emitted infrared, because it's the clouds and the water vapor that cause all those changes. But also you'd like to know what caused the changes, so you want to know about the clouds and the water vapor. And we have pretty good instruments up there now for measuring clouds and water vapor. The MODIS instrument on the Terra and Aqua satellite, very good at measuring cloud properties. The Ceres instrument, that's the radiation budget instrument, it measures year-to-year variations pretty well, but the absolute accuracy is only 3 or 4 watts. I'm talking about changes of 1 or 2 watts. The global warming signal from extra CO2 in the atmosphere is an extra like 1.6 watts per square meter of trapping. We can't measure it from space. What is supposedly causing global warming, increasing CO2, We cannot measure from space its effect on the radiation budget because the instruments, the satellite instruments, are not good enough. It can only be measured or can only be computed theoretically. Now that's an interesting thing. Climate models then are based on a theoretical relationship between carbon dioxide and the radiation budget. What I showed you was an actual observed year-to-year change in the radiation. So I'm showing you a climate mechanism that's actually measured. Increasing CO2 is a mechanism that has to be theoretically computed, which is an interesting point.
Just to comment about this solar influence, there is about, from the times of Galileo, there is data on the solar activity, sunspot activity. And the new results show that this solar irradiance is strongly related to solar activity. And now there is much indication that the solar activities and this irradiance is going down.
Well, this is, go ahead.
Going down. Okay, that's a small comment about the sun, and then there is this global cooling about the last 7-8 years. The global temperature is going down. Just a comment. But then I have a question. What about this TDO? Is it some kind of model?
No, it's an observed, it's an observed relationship of weather patterns out over the Pacific Ocean.
What kind of observations is it?
Wind, sea surface temperature, and I'm not sure what else. But pressure?
Yeah.
Atmospheric pressure. So it's an observed phenomenon. It's not theoretical.
Globally.
No, it's in the North Pacific.
North Pacific.
Yeah. But we know that everything is connected. When there is an El Nino, in the east, which is mostly the eastern half of the Pacific, it changes global temperatures. The whole Earth warms during El Nino. So regional changes can have global effects. Now, on the solar thing, you have to be, just because the sun changes in total solar irradiance with, let's say, sunspots. Let's say sunspots change, sunspots go away, solar irradiance goes down. If it only goes down by a little bit, that means you have to have positive feedback in the system in order to amplify it to see the temperature changes we're seeing. So people that advance theories that the sun is controlling climate have to recognize that if the change in solar is small, then you have to have positive feedback in the climate system in order to cause the temperature changes we've seen. And if you have that much positive feedback, then global warming will be a problem because the extra CO2 is probably even a bigger effect. So that's why it's a complicated, the whole issue is feedbacks are the single most important unknown about the climate system. We need to know what the feedbacks are. If we know what the feedbacks are, we know how much man-made global warming there will be.